All right, so this is the key to the practice quiz number 2, and you just needed to solve this quadratic equation. And I did mention that this quadratic equation, you could either solve it by factoring or you could solve it by using the quadratic formula. So let's go ahead and do the factoring first. So this quadratic equation is factorable. And regardless of whether you factor or use the quadratic equation, it must be in standard form. So you must have 0 on the other side, which we do, and it is in descending order, meaning that the largest exponent is listed first, or the term that has the largest exponent is listed first. The term that has the exponent of first power, x to the first here, is listed second, and your constant is listed last. All right, so when factoring this, the first thing you want to look for is to see if your three terms have anything in common. So you want to try and factor out the greatest common factor if possible. Well, these three terms, the only greatest common factor that they have in common is the number 1, is the factor 1. So basically, since it's just a factor 1, we're not going to factor out a GCF. The next thing you want to do, since I told you it was factorable, since this is a quadratic trinomial, you want to go ahead and factor it as two binomials. Just make sure that you notice this is an equation. This that you write next must also be an equation. And notice it's equal to 0, so you got to say equals 0. Okay, so don't forget about that. All right, so remember we're going to use the reverse FOIL. So we can use the idea of FOIL, first, outer, inner, last, to determine what terms in here need to go here, so that way the product, this binomial times this binomial, will give me this trinomial. Okay, and since remember in factoring you can use reverse FOIL, so let's do the F first. F for first, outer, inner, last. So to get that first term I see here, I'm going to look at the first terms that's inside the two sets of parentheses. So what term times what term is going to be 2x squared. Now since 2 is a prime number, the only thing that's going to work there will be 2x and x. All right, so that was easy because 2 is a prime number. So there's only one set of factors whose product is going to be 2x squared. And so it did not matter whether I put x here or 2x here, did not matter. All right. Okay, so 2x times x is 2x squared. So the F of FOIL looks okay. Then we can go to the last. Always go to the last. So the last meaning these terms in the second term that needs to go inside this parentheses and this parentheses. So again, the same way we did this, 2x times x is 2x squared. I'm asking myself, what term times what term is a negative 2? Now notice I said negative. The idea is that when that constant is negative, that means that in order to get a negative, that means that one has to be positive, the other one has to be negative. All right, and determining whether this is positive or this is negative is that idea of trial and error. All right, so I'm going to go ahead and use a separate sheet of paper so I can show you that if you make a mistake, it's pretty easy to determine how to fix it. So I'm going to go here and redo this little part so I can make a mistake. So let's say I put 2x and x here, and the only and remember 2, although this is negative 2, 2 is a prime number, so it did not. So there's only one set of factors whose product is 2 and 1. Now be careful, make things easy on yourself. If you put a 2 here and a 1 there, and you ask yourself, well, 2 times 1 is 2, that is true, right? That is true. But keep in mind that if you look at this factor right here, you could factor out a 2 from here, because both of these have a 2 in common, which meant that if you can do that, then all these terms are divisible by 2, and it's not, because 3 is not divisible by 2. All right? 2 is divisible by 2, negative 2 is divisible by 2, but 3 is not divisible by 2. So that means that what I have here is incorrect. So if you did that, then you could use that idea and notice, hey, this can't be right. So that means then that maybe I need to put Let me go ahead and rewrite this over. That maybe I need to put 1 here and 2 here. All right? And remember the last sign's negative, right? So that means these signs in here have to be different. One has to be positive, one has to be negative. So let's suppose, I'm making this up, let's suppose you put a positive here and negative there. All right, so my first is okay. 2x times x is 2x squared. Now let's do the last. A positive 1 times a negative 2 is a negative 2. So my L is okay. Then I got to check the out and the inner now. So the out and the inner is going to be this positive 3x. So when you add them up, you should get this to be positive 3x. So let's check it. The outer, 2x times a negative 2 is a negative 4x. The inner, 1 times x is x. When I add them up, 1x and a negative 4x is a negative 3x. That is not what you wanted, right? You wanted a positive 3x. Well, that's easy because those are opposites. So what it means then is all I need to do is change these signs. So then I'll get 2x minus 1 times x plus 2 equals 0. And if you check it using FOIL, if you check it, you'll see 2x times x is 2x squared. The outer, 2x times 2 is a positive 4x. The inner, negative x times x is a negative x. And the last, negative 1 times 2 is a negative 2. Combining like terms, I get 2x squared plus 3x minus 2 equals 0, which is what you wanted. All right, so that means then that this trinomial, when I factor it, is going to be this product right here. So let me go ahead and put that now. So this becomes 2x minus 1 times x plus 2. All right. Now the next thing you got to do is remember I have a product of two factors here whose product is 0. So that means in order to get a product of 0, if you have let's say two numbers whose product is 0, then one of them better be 0. All right, well, these are two variable expressions, two factors whose product is 0, so one of these has to be 0. And what you do is you use a zero factor property. Notice I'm saying the zero factor property. All right, zero factor property. So you can use a zero factor property, and you're going to set each of those factors equal to 0. All right, so you got to show that. So you go from here to here. And notice I went from a quadratic equation. So the solutions to this quadratic equation are going to be the same as the solutions to each of those linear equations. So I went from a quadratic equation to two linear equations. So the solutions to this quadratic equation will be the solutions to each of those linear equations. So when I add 1 to both sides, I get 2x equal 1. To get x by itself, I'm going to divide both sides by 2, reduce. You get x to be 1/2. So there's one of your solutions. Over here, to get x by itself, right now I'm adding 2. The opposite is to subtract 2, which you do to one side, you do to the other though. Combining like terms, a positive 2 and a negative 0. X plus 0 is x, equal 0, and a negative 2 is a negative 2. So there's the other solution. So those are your two solutions. All right. So that is using factoring to solve this equation, because I did tell you it's factorable. Now let's use the quadratic formula. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac. Now when using quadratic formula, I'm checking for this. Your form must be correct. The structure must be correct. All of this, not just this, even the opposite of b, needs to be divided by 2a. So I'm going to be looking for how you wrote this. All right, so let me go ahead and rewrite the equations. Here is my equation. It was already in standard form, which is what we want. And the a, b, and c you see here, and remember the standard form of quadratic equation is ax squared plus bx plus c equals 0. So a is the coefficient of x squared, b is the coefficient of x, and c is your constant. So in this case, the coefficient of x squared is 2, so that's a. The coefficient of x is a positive 3, so that's b. And my constant c is negative 2. Not 2, negative 2. And then we're going to take each of those numbers and plug it back into the quadratic formula. So therefore we have x equal, we're solving for x, so x equal, the opposite of b. Well, b is 3, a positive 3. The opposite of a positive 3 is a negative 3. Plus or minus the square root of. Then I take b, always put that in your parentheses. And so b is 3, and I'm squaring that. Then I'm going to subtract 4 times a, which I know is positive 2, times c, which I know is a negative 2. And all of that, so that's, remember I told you about this division symbol. Then you need to say, starting with negative 3, you need to do this. And I got to see this. Don't just put that division symbol with this. Even though you get your final answer correct, your form's not correct. You're missing this little piece here. All right, it's got to extend, so you're not going to get full credit. All right, and all that's being divided by 2 times a. Remember, a is 2, so that will be 2 times 2. Okay, let's go ahead and simplify this. So we get negative 3 plus or minus the square root of, and then we're going to simplify the discriminant. So the discriminant is the expression that's under the radical. With a quadratic, let me rephrase it. With a quadratic equation, the expression that's on the radical is called the discriminant. In general, this depending, like if you had, let's say, the cube root of x plus 3, then we call this the radicand. All right, so sometimes you'll hear people call this the radicand, but if it's a quadratic equation, then we normally sometimes just call it the discriminant. So let's go ahead and simplify the discriminant. And when I do that, I get 3 squared is 9. Order of operations, think of this as a negative 4, even though it says subtraction, because remember, subtraction is adding the opposite. So I can think of this as adding a negative 4 times 2 times a negative 2. So a negative 4 times 2 is a negative 8, and a negative 8 times a negative 2 is a positive 32, right? All right, so I get 4 times 2 is 8, 8 times, negative 4 times 2 is negative 8, negative 8 times 2, oops, sorry, that's positive 16, excuse me, positive 16, okay? So 8 times 2. I don't know why I said an extra 4, but positive 16. All of that is being divided by 2 times 2, which is 4, okay? So I get negative 3 equal negative 3 plus or minus the square root of 9 plus 16. That's a 16. Let me go and just do this then. 16 is 25, all divided by 4. Okay, now you need to simplify your radicals whenever possible. 25 is a perfect square, so that means that the square root of 25 is going to equal 5, because 5 times 5 is 25, right? So this becomes negative 3 plus or minus 5 divided by 4. Don't put the square root of 5, because remember, the square root of 25 is 5, not the square root of 5. All right. Then once we get to that point, then one of the things you saw is that, hey, since I no longer have square roots, then my solutions are going to be rational. I'm going to end up with rational solutions. And so since I'm going to end up with rational solutions, then I'm going to go ahead and break this down into what it actually is. So this becomes negative 3 plus 5 divided by 4. And the other one's going to be negative 3 minus 5, that's a 5, divided by 4. And then simplifying the fraction, negative 3 plus 5 is 2, so I get 2/4, which reduced is 1/2. So you have to show that. And then negative 3 subtract 5 means negative 3, and also plus a negative 5 is a negative 8. And negative 8 divided by 4 is a negative 2. So those are your solutions. And notice you're going to say x equal 1/2, comma, x equal negative 2. And notice these right here are the same as these. Okay? All right, so that is it. So that is the key to practice quiz number 2.